characters by frequency. Although you can see, okay, Aryan, it seems like an easy problem, we can do it by ourselves. It is good, you should try it by yourself, but it's actually a very good problem to learn and understand how we progressively increase and how optimally we can reach to a solution. In an actual, like the interviewer should feel like that we are actually thinking in that direction, and that's the reason we thought about that specific approach. Let's see what do we mean by that. We have given a string S, and we have to sort it in the decreasing order based on the frequency of characters. Again, sort it in the decreasing order based on the frequency of characters. Now, the frequency of characters is the number of times it appears in a string. So let's say if I have a string ARYAN, so you can see A is occurring 2 times, so the frequency of A is 2. Let's say if I would have said ARYAN, then A is occurring 1 time, this A is occurring 1 time. Right? Okay, great. Now return the sorted string. If there are multiple answers, return any of them. Now what he mean by this is we have to return the sorted string. Sorted string according to him is the string which is sorted on the basis of their frequency. So A is occurring 2 times. So A has a frequency of 2. So it has the highest frequency. So he should come first. Okay. Then other, then Y, then Y, R, Y and N. And then he said that if there are multiple answers, which means, as you can see, frequency of all the others R, Y, N are all 1. But he said you have to sort it in the decreasing order based on the frequency of characters. That's it. He didn't say anything about the characters itself. R, Y, N, if something is small, it should come first. Nope. He is only concerned about the frequency. Again, let's say you will say A will for sure come first because he has the highest frequency, which is 2. Then my R, then Y, then N. Again, the correct answer can also be A, Y, R, N. The correct answer can also be A, N, R, Y. But the incorrect answer is N, R, A, Y. Because A has the highest frequency, as in the frequency of 2, so he should be for sure coming first, or as in before the frequency which are lower, because N, R and Y have a frequency of 1. So this is the problem says. Let's quickly have a look at the example. As you can see, TREE, so you can see that E has a frequency of 2, so E should come first. Okay, E should come first, and then R, and then T, or then R. Both are actually correct. As you can see that EETR is also a valid answer, because he is only concerned about the frequency. That is one thing which you have to make in mind, because it is a very, very, very important thing to actually make you figure out the most optimal approach for this problem, this specific problem. So please, everything makes sense, right? Now next is CCCAA. As you can see, both have the same frequency, which is a frequency of 3, so anyone can appear. So answer is AACC. It is also correct. And also answer of answer of that CCCAA, it is also correct. Now he said that CACACA is incorrect, as the same character must be together. That's one thing. And okay, you have to also make sure that it is a question which you can ask the interviewer, sir. And again, it's an edge case which you might end up thinking, but usually you might end up not thinking, because you will simply sort it all together. By default, you might be thinking that, okay, I will for sure sort all together. But it's a good edge case to ask the interviewer, sir, is it possible or not? Now, last but not case, that we have a B, which will for sure come first, and then a A, or then A. Anything can come first. As you can see, A and A are treated as 2 different characters, so it will not count as a frequency of 2. Remember that. So this will not be a case, because this A and this A are 2 different, so both have frequency of 1 individually, while B have a frequency of 2. Now, so for simple one thing, the problem asks us that simply sort it based on the frequency. So I know I will have to get the frequency. So if I have these characters AABB, firstly I will have to get the frequency. Again, I am doing exactly what the problem is saying. Firstly, this is a string, I will get the frequency of all the characters. Now I will simply sort the string based on the frequency. And how we do it? Sorting are in simple comparator function we use, right? So we will simply sort the string based on frequency, which we have found out just now, and then I will get my output string. As simple as that. And when I say sorting, how simply a sorting happens, like sort s dot begin and then s dot end, and then you have a comparator function. This comparator function will go and compare each character of the string. Comparator function just takes the input what you have passed in. You have passed in a string as an input, so he he means as in the comparator will take two characters from that string and then we'll grab those characters and then we'll compare them based on some condition. That is a comparator function. We'll see. No worries. We'll see how the comparator function works for the ones who are not much familiar with it. But most of you must be familiar about the comparator function. So this is exactly what we will do. We will just simply grab the frequency. As you can see, I know that I have either lowercase or uppercase or digits. So in total, I will have 26 lowercase, 26 uppercase and 10. But I don't want to go into the ASCII values of them. So I just took, okay, 128 as a ballpark number for us. As in like all the characters whatsoever possible, I just took 128 for them and then I just went on and increased the frequency. Again, this will actually go and convert the character into its ASCII value, and ASCII value can come in 128 characters. Remember that. Okay. Now I just went on. Now my frequency, I have grabbed my frequency. Now my next task was to simply sort the string. So I'll just simply go and sort the string S based on the comparator function. Comparator function, as I told you, it's simply, although you can write a different function also, but comparator is exactly working for this specific code. So it is good to write that as a lambda. Now usually people write lambda here itself inside this portion itself, but I have a habit of writing lambda differently so that it looks good. Clean code. Although clean code, people might say okay, lambda should be inside, but yeah, this is what I consider as a clean code. So lambda is okay. This comparator function will go. Now this, see what a quick help for this actually means. This address says that anything in the code outside I can actually access it, and this says okay, I am comparing these two. I am from this string S, at a point of time I will be comparing two characters to see who should come first. Now I am saying that although by default whosoever has a frequency, whosoever has a higher frequency should come first. Whosoever has a higher frequency should come first. Right. So as I told you, like my prime aim was whoever has a higher frequency, it should come first. So if frequency of A, if it is more, then he will come first. What if the frequency is same? If the frequency is same, then you can do anything. You can also have a is less than B, or you can also have a A is more than B. Anything you can do. Here I just told okay, A is less than B. Now when this comparator function will sort it down, I'll simply return my string S. So you can see that you just did hashed, which means you used a hash map to get the frequency, and then you simply sorted the entire string of size n. As you can see, entire string of size n. So it's a simple what the problem was saying. So it is n log n because you sorted the entire string of size n, and for sure the space is also log n because for C++ and Java it's just a heap space which uses while sorting, and for Python it is O of n. Now, if I ask you, can you please improve it? So you will go back and look at what you did previously. So what you did was, so you had the string, you made the frequency out, then you sorted the entire string. And because of that, you sorted the string of length n. But there's a catch. There are 26 lowercase letters, 26 uppercase letters, and 10 digits. Which means at max you can have k distinct characters. So why to sort all n characters? Sort just k distinct characters. Aryan, what are you saying? How I will sort k? Array, you know that you in the string of length n you only have k distinct characters, and every character like this entire length will be just k because you have only k distinct characters. K, I just told it is a maximum limit of k is this value. Now I'm saying that you did and sorted the entire string. I'm saying okay, you have to sort on the basis of frequency. Whosoever is a higher frequency, you will just simply get that first. But higher frequency of a character, right? You know that you have at max k distinct characters. So simply get those distinct characters out, get those frequency of those characters out, and simply sort those k characters only. Not every character. Because I cannot duplicate characters, which means if I have a, B, B. So earlier I was sorting 5 characters. Now I know A is occurring twice, B is occurring thrice. I will now say just sort 2 values, this and this. So he will say okay, my input is k values now. Earlier my input was n values. My n values, I was sorting my 5 values earlier, 5 values. Now I will sort just 2 values, and thus I will sort okay, B will come first and then A will come. This is how I can, again, Aryan answer was B. Okay, great. I know that I will simply sort it down. So this will become a B3, which means sorting it down on the basis of frequency B3 and A2, and then expand that in O of n time. See, sorting took k log k time, but then expanding will again take O of n time only. So I'll just simply expand that B, 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 A. And that's how I expanded it, and again O of n time. So this operation took O of n time. This took k log k time, and this took O of n time. So this is from where you actually reduced your complexity from n log n to k log k. So exactly same thing. If we had this input string, firstly we will have to make a hash map, because we want to sort on the basis of frequency in the decreasing order. That's a prime aim for us. I'll get the hash map for us, in which although in C++ you cannot directly use hash map for sorting, as in like you cannot directly sort the hash map. So you have to get the hash map in a vector of pair. So this is a vector of pair for me. A pair has a character and its frequency, a character and its frequency, a character and its frequency. Now I can sort this vector. So in C++, I cannot sort my hash map, right? So I'll do the same thing. That now people will start asking, Aryan, why not you took the map itself, which will by default sort C? If you use a map, then you will insert in the map n times, so that will foreshorting n log n time. So firstly take an unordered map, get the frequency out, then get those frequency out in a vector, simply vector of pair as in a character and its frequency, and then simply sort that vector only. So I'll simply sort this on the basis of frequency. Now frequency is the second part of the pair. Okay, it is sorted. Again, for the ones which have the same frequency, do whatever you want. And then when this is done, you can simply expand that. Okay, B occurring twice, so expand B and append it 2 times, append B 2 times, append A 1 time, append A 1 time. And that's how you can simply reduce your complexity from n log n to k log k. Again, an operation will for sure occur. O of n will occur here, O of k log k will occur here, and O of n will again occur here. So I'll just show you the code. Exactly simple. That firstly we get the frequency as we were doing earlier also. Now we just took a vector of pair of character comma int, because you know that we cannot sort the unordered map, and we also cannot use map because it will push in all n elements in the map, which will take n log n time. Now I will just have a frequency ARR. Now in that frequency ARR, I'll just push back the character and the frequency of that specific character. Now I need to sort this frequency ARR array. So I'll just simply sort this frequency ARR array based on the comparator. Now comparator again will compare on the basis of its frequency. So this comparator now takes two things from this frequency ARR. Now these two things are a pair of character comma int. One thing is a pair of character comma int, other thing is also a pair of a character comma int. So he will take two things, A and B, and then he has to compare A and B based on one factor, which is its frequency. So whosoever has a higher frequency will come first. Okay, now again there is like, you can also add the if condition stuff, but that is not required, because you want to only consider about the frequency. That's it. Now when this is done, you have your frequency ARR sorted. Remember, your frequency ARR, this entire thing is now sorted. Now if this thing is sorted, you can simply say that iterate on it, and now you had your B occurring twice, so append your character B 2 times, frequency number of times. So again iterate on my frequency ARR, because now it is sorted in the decreasing order of their frequency, and I will keep on appending my character that many frequency number of times, and I can simply return my answer. So that's how my now complexity is O of n plus k log k plus O of n, and space is also O of n, because now I'm using unordered, like I'm entirely using this entire thing. Like in worst case, for sure the hash map can go to O of k, that is true, but it is kind of n or k both ways. And like not only this, but also this thing can go O of k times up again. Like if k is less, I can say minimum of n comma k. Now this entire thing again will go to O of k times, because you have those number of frequency of characters, and this entire thing answer is never considered in the time complexity itself, but this entire thing will take O of log k space. So this kind of says k, but we don't have an actual operation of k, so we can say it is O of n itself, or O of k also you can just consider. It is kind of minimum of O of n or k. N or K, minimum of any of them. Again, the same you can just apply here also, that you are using this frequency which is O of K itself, and but here the space which is used, it is actually a log of n for specifically C++ and Java, but otherwise it is O of n for our different language, which is Python. So you can say that it is O of n plus K and it is O of log n plus K, but that's okay because K we never considered for the question number 1, so we can just consider that as a constant part, because actually it is constant. K is actually constant, so we can just ignore that part also. Now, but if the size is very less, so n can be considered as constant. So a bit here and there about n and K for your knowledge. Now coming on back, that again the interview asks you, can you please optimize it more? Now there is no way remaining for you to optimize. The next thing which you can think of is what you were doing while you were sorting, right? The only thing which you did or which you optimized was that you had a specific string, you get the hash map, and then you, again, earlier you were sorting the entire string, then you got the pair, only the K distinct characters, and then you were sorting it. Now you have to again optimize it, which means so far you optimized the sorting itself. As in, now I'm saying we have to again reduce the complexity, which means earlier it was O of n plus K log K. So K log K, O of n the for sure will come, because we have to iterate on all the characters again. Just one thing, one reminder, this is O of n because it is iterating on all the characters. That's one thing which I for sure greatly missed. It is also O of n. So O of n will for sure come in picture. But yeah, we have to iterate on all the characters. So for sure O of n will come in, have to come in picture. But yeah, it's for time. Cool. Now coming on back, we have seen that okay, we had O of n plus K log K. So for sure we have to reduce the complexity now. So O of n, which means you have to iterate on all the characters for sure. So that is that. So O of n factor, it cannot be reduced. Now coming on to K log K. If I want to reduce the K log K factor, it was because of my sorting of K distinct characters. Now I am saying I have to reduce that also, which means I will not use sorting by default sorting at all, which means the sorting which gives me log K time, I will not use that. But Aryan, ultimate aim was to sort on the basis of the frequency in the decreasing order, so I have to sort it. Yeah, okay, so I have a dilemma. I have to sort it also, and I don't have to use the sorting also. If I have to sort it, I don't have to use the sorting, so I will use my own sort, which is the bucket sort. See, it's actually, see, I want to reduce the complexity, so I don't have to, I will have to get rid of the sorting, but I also, the question also says that you have to sort. So you have a dilemma. You have to do it and not do it. So simply use a sort which will not do sorting. As in, like, it will do sorting, but it will not use the sorting time complexity. So it's the reason we use the bucket sort. Because again, the another thing which actually makes us believe that we can use bucket sort is that bucket sort is used. See, the indexes are used as a frequency, and in those places, in those cells, in those buckets, I placed all the characters having that frequency, and I know that my length is n. I can have at max n n. I can have at max n same characters. I can have a n times, small a n times. If I can have small a n times, so for sure the frequency of small a can be n. So I know that the maximum frequency of a character can be n. So I can make a bucket of size, n, and then, as in like n buckets I can make, and then from those buckets I can just say, okay, if this was the frequency which I had made earlier, that a will occur once, small a will occur once, small b will occur twice. So I can just say occurring once. So whosoever, again, this is a frequency, and bucket sort, how it works is frequency, and then you just say, okay, these characters have this frequency. So one frequency is by character A. Frequency 2 is by character B. So now what will happen is I will iterate on from the very back, because back indicates highest index. Highest index indicates highest frequency, because it is indexing or representing the frequency of that character. So I'll iterate on from the very back, and then I will just whosoever occur in my list, I'll just get that, append that character index number of times, right? And then simply again move back, and then again append it again. The fact that my character sorting doesn't matter will actually be helpful here, because here in the bucket you have just pushed those buckets. here I have pushed A and then a big A, but actually a sky value of big A is actually less than the small a. So if the problem would have asked us that, bro, you have to sort it also on the basis of your sky values, then it might have been a bit complex to use bucket sort, as in like you have to again sort this entire window length entirely. But we don't matter. That's the reason it specifically impacted our problem, that we can actually reduce the complexity by a lot number. So again, we'll just enter it from the very back. Whosoever has some value, just simply iterate on that. Okay, yes, you have a B, so simply append B 2 times. Then you have a 1, then you encountered a small a. Okay, append small a 1 time, and then append big A 1 time. And that's how you can simply solve it. Let's see how the code will look exactly same. Firstly, we'll get the frequency, right? Then we will go on and have a bucket. My entire bucket data is the array of size n plus 1, so as I can have indexes from 0 to n, and then I will simply iterate on the entire frequency unordered map, and then for every frequency as an index, I will push back that character. Now when this portion is done, I will simply have to make my string. I will go on my bucket data from the super end, which means I equal to n. I'll go on from I equal to n, which means that it is the index. Frequency is the index. So I'll go on from the very last index to the first index, and then for every index, what all characters are there in that specific bucket of that specific index, just get me that specific character and append that character frequency number of times. Append that character frequency number of times, and then just keep on building your answer, and then simply return the answer. Thus you saw you never used your k, as in like you never used the sorting, by default sorting, which was taking k log k time. So the time is O of n, because you saw it is O of n operation. Again, it is O of n operation, or you can say O of k operation, anything whatsoever you can say. And then it is again O of n operation, and that's how you can simply solve it. Again, you might end up saying, Aryan, it is O of n into your worst case, you can have k distinct characters. True. But again, that is O of n into k, but you might just end up saying it is constant, all that stuff, because you are going on to n characters, and then your each bucket data, because your each data, which means as in each bucket, can have distinct characters, and you can have k distinct characters, so it might end up happening n into k. But again, that's a caveat which you can actually say, okay, it depends upon the test cases and stuff, but it can actually say n into k, but again k is constant, so you can actually ignore that also. But you can say the same thing as earlier, you had n plus k log k is constant, so this k log k is also constant. Again, that is also true. So there is a small catch, as you can see, with k itself, that okay, how you actually try to infer the k, but you should tell all the approaches to the interviewer that, sir, but Aryan, it is not k log k, n into k, because if you have a bucket of length n, at max you can have k distinct characters. Let's say here are 2, here are 3, here are, let's say, these. So in total I will not have k for every of my index. I will have k for in total I will have k distinct characters, which I will be iterating on. So it should be n plus k, not n into k. Remember that word. But again, you can just say k is constant, all that stuff, you can ignore that, but still it is reduced from the above time complexity from n plus k log k to n plus k kind of. But yeah, that is how we can actually improvise that. Again, k is for sure constant, which is 128. Again, it is less than 128, which is actually k is nothing but r 26 plus 26 plus 10. This is the actual k, but still we can just let the interviewer know that this is the entire case for us, and ultimately we can return the answer. Space is also O of n, because we are actually using the entire bucket of length n. Cool, thanks for watching. See you later. Take care. Bye bye.